Right, does that work? There we go. Hello. Welcome, welcome, welcome. How are we all doing? So the music wasn't playing. It is now. Yeah, so I'm completely unprepared. Just switch on the other light. Eh. The last stream, we was wrapping up on the tile binning generalization. Um, yeah, so we made a general tile binning API so it can tile bin just random objects into screen tiles. Um, probably view those. So we've got like, I think 16 by 16. Yeah, there you go. We've got these lovely screen tiles, and each of these has an array of objects. So more specifically, an array of ellipsoids for the ellipsoid ray tracer. So each pixel can look at the tile that it's in, and then get an array of items to test against. And that'll mean I have a smaller set of tests to do. We have a full screen worth of objects to render. So I made a general tile binning thing because I've kept making them and I can't be bothered to yeah, I just wanted to make one that I could just reuse, and because the whole UI is tile binned as well. So off stream I spent some time and actually ported the UI renderer over to use this new tile binning API. So if we take a look in the code base, or one, if we take a look in the at the profiler, you'll see we've got this UI scope now, and it has some tile binning, everything to do with tile binning. So tile bin setup, bin all the UI objects into the screen, we'll just emit them basically, and then do the sorting into the tiles, and then find the ranges where each of the arrays start, and then off you go and do the UI rendering. Um, yeah, so there's a lot of entries being printed out here, and it's a bit hard to follow now. So I also went and spent a little bit of time on making a built-in profiler into the game. So that is been worked on behind the scenes. But I do want to get back on Linux over Christmas, so I might get back going onto Linux before I carry on that work. I can show you guys how the profile is looking at the moment. Um, but yeah, it's going to be good. I'll be able to press a button and boom, numbers. Wait, just dealing with some Windows development things right now. We'll be booting up in a second. Right, here we go. So it looks something like this. It's a bit noisy because I think other processes run and interject, but if I were to pause it, yeah, there's gaps here. I think other processes are able to sneak a compute shader in. I'm not sure. But yeah, so this is how the profiler would look rather than doing this sort of thing. And you can sort of zoom in with the arrow keys and take a look at, you know, things. There's also different modes as well where we could change like how we measure basically. Do we put barriers down after every single command and have a measure a single compute shader getting full access to the GPU, or do we don't put the barriers down and allow them to overlap, and that will mean the timings won't necessarily be correct, but yeah, it'll be the frame time would be shorter though if you choose things to overlap or not overlap. But yeah, it's cool. So I've been working on doing that off stream. Hopefully we'll get it ready soon so we can actually use it. I'm a bit concerned with these spiky times though. I do think that is because OBS is running now and it is inserting, see here's massive gaps at the bottom. I think this is just due to the GPU getting time slicing out to another application. It's a lot. It was a lot less noisy when I wasn't streaming, but there was still some noise that showed up every like 4 frames. Um, hey Robo, welcome, welcome. But yeah, so this would be pretty cool. Pretty happy about it. So we've got like the ellipsoid renderer. You can at least just look at the big scopes and just see. And then this is all the, the tile binning is happening there. And then wait, what's that? Tile bin ellipsoids. Oh, then the debug renders are there, right? Yeah, then some debug rendering of the tiles, and then the actual ray tracers there. So yeah, we can see big stuff quite easily, which is nice. And there's the UI, right? So we've got these scopes that can help us find things. But yeah, this will be a thing that we'll use a lot in the future when it's done. But today, what I want to get started on working is the we've got the rendering good now. We've got the 3 different anti-aliasing things. We've got ray traced anti-aliasing, a software version of MSAA, and obviously a super sampled anti-aliasing one for the sort of ground truth of how good stuff could look. So now we've got those, and I like how they are. Now we're going to try and scale up to an actual scene, so we need to be able to produce models that can then get instanced. So we've done this in the past, so I do kind of know what to do. We also have a lingering API about for the old one, just in case we get stuck or anything. But so I think today we need to start off by porting a custom allocator. So we can, so effectively these models are going to be loaded from a custom asset file called like a compiled one to be binary, and it would just have all the binary data for a model, so it just has all the ellipsoids in there, and those will get loaded into memory whenever the asset is in the level or nearby or something, depending on how the game goes, right? So we need a way to basically have one big buffer where we have all the ellipsoids for the models, and we need to basically like heap allocate, sub allocate from that buffer, basically. So we need to port the so this was originally the BVH node allocator. Then when I made the temporary resources for Vulkan, I took it and made it into a custom allocator for, heaps. Well, allocating blocks of memory from different heaps. So I think I want to take this custom allocator for the Vulkan backend and change it so we can allocate ranges of a buffer, right? Sub-allocate a buffer basically. So it's going to be a little bit more simple. This one allocates more heaps whenever it runs out of memory. This one that we want to write has the option to return null because you ran out of memory. There's no room to put the model, and in that case, we've got to gracefully handle it. So if we can take all of this API, we can just repurpose it for something like so graphics internal header. Oh, that's the old one. Can I just close everything? By the way, did everything compile on Windows without changes? I remember supporting the Visual Studio is kind of wonky as opposed to C++. I just use Clang. So I just use a build script. This one. So I just use Clang. These are all my arguments, right? I got a bunch of include things and extra warnings and stuff, and some linking arguments. Um, yeah, and obviously I have my library dependency to Vulkan. But yeah, everything else is single header libraries, and I just use Clang because Clang is a cross-platform compiler. So I'm just trying to stick to Clang, but I do try and stick to standard C. Though I got the this flag here, so it tries to warn me if I step out of doing anything non-C standard. Um, but yeah, um, that seems to be okay. Although Visual Studio is just kind of buggy, you know, and yeah, I think I found out the problem when it opens up the same file again, but one with backslashes instead of forward slashes. If you see here, it's got like backslashes. Well, sometimes it'll open up the same file again, but with like a forward slash in there, and maybe it's a relative path. Well, it turns out that's because when you run the debugger, it loads, it can't, for some reason, Visual Studio doesn't work out. It doesn't like resolve the path into a full, it doesn't like get the real path, resolve all the symlinks and figure out it's the same file. So it opens up two of the same files and pain. Anyway, I'm hoping to get off for Windows. Hoping this will be my last stream on Windows. Because I won't be here on the 24th and 26th, which is when I usually stream. I'm taking those 2 days off. Spend it with the family and everything. And then I'll be back obviously next Sunday. So I'm hoping to be on Linux by then. But yeah. Right, so this is going to be kind of maybe like a range allocator. Probably call it that. Didn't we already have one of these? Well, that's not going to be helpful, is it? Yeah. I think I already started making one of these and then I changed my mind. I forgot what it was. Right, so we're not really going to have heaps anymore. It's going to be backed by a buffer, basically. We take all of that. Look for capital letters. I was getting confused with these ones. Which one means capitals and which one means match whole word? So we don't need this one. Yeah, this might need to move. To here. So since it's a GPU range allocator, GPU is only, I think my buffers is most can have 4 gigs of memory anyway. So I think we can get away with a. Actually, no. This No, I did make it so we could do more than 4 gigs, wasn't it? Yeah. I was thinking maybe we could have got rid of the oh well. Made them all U32s instead of U64s. Cool. So let's just change one final one, vkmem. Nice. So let's figure out which functions we need to delete and everything. So this one gets deleted here because we don't have heaps anymore. There's just going to be blocks of yeah, different ranges basically, which are either allocated or not allocated. Right. No heap index anymore. Cool. So the way this allocator works is that effectively we waste memory. We just, whenever you ask for a piece of memory, we find the next power of 2 and then look in that bucket, and all those allocations have that power of 2 or more memory available. And you take that block and then you cut, you trim, you basically shrink that block, or you split the block into 2 pieces if it's not an exact fit, and then you return the allocation back to the user and put the other free block on the list again if it's still big enough to be used. So it just means we can, it's a very fast way to allocate memory, but you always have to have at least a little bit more memory around for it to work. There's no VK memory type index. Where do I put these TikTok bits? Put it here. That'll work. Right, so we instantiate the allocator, and we should probably have some kind of like yeah, so you probably pass in a capacity of like the buffer or something. That's what it should be called. When you allocate, you pass in a size and some alignment. So you could be thinking this could be dealing with bytes, it could be dealing with a range of elements, but also you can still align it by a certain number of elements, which would be quite handy. Because you can basically ensure like an index, if you had like an element index into some array, or like an element start index, you can line all your elements to like, to 32 or 64. And if you line it to 64, it means the first 6 bits are always going to be 0. So you could like get some savings and basically shift your element start index by right and save 6 bits if you're already packing stuff down. Yeah, so could be quite efficient that way. But again, you just waste a bit more memory because you're just over allocating, which is fine. Yes, on the analog function, dalloc. There's no device memory thing because it's not a Vulkan memory allocator. This one. Reset. Do we even need a reset? Maybe. Print for debugging, yes. Validate and test. Port those over. So I don't need a heap anymore. But we will need a block allocate. That just gives us a new block. Back. For us to use this in internal function. Block DLlock, unlink from free list, yep. Find for insert, find a bucket, index for insert, or find. And get the block size. Cool, cool, cool. Right, so that's the API. Now we need to actually like copy over the implementation and port it over. Hey Rohan, how you doing? Yeah, doing good, man. Doing very good. I'm off for Christmas now, so it's been, you know, well, it's just been the weekend, but this week's going to be preparing for Christmas because we're hosting Christmas on Wednesday. So yeah, more shopping. We went out the other day, got a few last minute presents. Um, but yeah, um, what else? Yeah, things going pretty good. How about you? How have you been? How's your FPGA stuff going? Oh, yeah. Also, built myself a little profiler into the game. Still work in progress though, but getting there. I'll be able to like press a button and boot into maybe I can show it. It's pretty cool. Why did I do C++? I'm too used to work when we in Visual Studio. um what am I trying to look for? Oh, it's still enabled. Yeah, so there's a it's turned off by default because it's not ready yet. It's nearly there though. It freezes the game if I switch modes. They got this like profiler. So it used to just print out to the terminal, but this has just become really unreadable. So I thought, I have a UI system. I should get it to be able to render it out. So I can pause it with a space button and zoom in with the arrow keys and sort of see how long things take. So the ellipsoids to render, you know, it's about 1.4 ms with some debug things rendering. Yeah, hopefully this scales up well. We'll see when we put tons of models in there. Yeah, there's some gaps that appear. I think this is because OBS comes in and distills some of the time slice. But yeah, there's the UI. The UI is using the new tile binning thing now. They got this sort of like tile binning API where it's just made it really nice and easy to just bin any object I want into screen tiles. So it's pretty sweet. Easy for the UI and the ellipsoid system now. Yeah, if I press the Alt O key, it stops them from overlapping. Or means they can overlap, so it can increase the times of the or decrease. Yeah, you can't really see it much. But yeah. It's pretty cool. I'm hoping to be using that very soon. Be very useful. Hey Kat, how you doing? Hey there, Pete. No, so I was wondering if you can add something like that rather than the console spamming. Yeah, it's got really bad. So I took my UI system and I was like, let's get it using the tile binning thing. I did it yesterday or the day before. Something like that, I forget. Time is weird right at the moment. But yeah, if you take a look, it's just complete spam. That's all the ellipsoids one. Oh, there's no UI happening here, but yeah, if I get some UI up, it'll be there. Yeah, some UI. There you go. So much spam. bit difficult to follow. But it's nice because you actually see all the times. So yeah. I've got ways to reduce as well with the new profile. I've got ways to sort of say only put scopes down for the, or put the outer scopes down. Don't record times for each dispatch. So we can always get rid of individual dispatches and just look at whole the scopes as a whole. Another thing we can do. Yeah, that'd be cool. I'm looking forward to that. So we're working on a custom range allocator at the moment because we need to take models from an asset file, which will be worked on when we do the model editor. And we'll have a buffer filled with every single ellipsoid from every single model. And every single time we load a model, we sub-allocate a range for all the models' ellipsoids and put them in the buffer. And, you know, if we unload that asset, we take that range and give it back to the allocator so it can then, you know, reuse the memory when another asset comes in. So yeah, we just run a generalized. I've taken this one from the Vulkan memory allocator that I made for the temporary resources, and which was originally the BVH node allocator. And so adjusting it so we can use it for any single. We're going to probably have a lot of these buffers where we're going to need to sub-allocate ranges, and this will be just the allocator we'll be using. It's just a heap allocator or a free list allocator, you know, whichever name you'd like to use. We'll figure out these things in a second. But yeah, gonna be lit. Gonna be amazing. Let's go to the Vulkan C file. And let's find the memory allocator. And let's take it all and change it how it works. Best part of programming. Having the answer. So where's the old BVH code which is commented out? Here we go, the node allocator. Let's put it in there. So let's get changing how this is named. Right, so there's one which is called. Right, so these do exist. We'll change it to. What was it again? Range. Neat. Next one. I think I can just replace all, to be honest. I think we're pretty safe. Let's find out. I could just look at Git and find it, I guess. And then that one. Here we go. Cool. So now we've just got to find all the mentions of the word heap and figure out what to do in this sort of memory index thing. FPGA stuff's going great. I'm doing. Oh, you're learning ASIC now with tiny tap out. Oh, I was tape out. Nice. Yes, I've heard about that. It's the way. It's a sort of affordable way to build your own chip, basically, isn't it? That's great. Yeah, it's gonna be awesome. Because the worst thing about a lot of the graphics tools that are available is they're in a separate application. So you either have to sort of boot the game up with that application, or their applications, where you have to use a specific one for a vendor, and it will like create a capture, and it's not really working with the live game, you know. and then you can view the capture, and yeah, so, and it's just got tons of information. You got to find the right pages where you need to look at, and you might not use it that much. But I think what's great about having it a very specific tool in the game, it might not do everything, but it just does the bits you want, that I want 99% of the time, I guess. And I can see it happening live, and I can pause it, and it just press a button, and it just comes up. So that's how it's gonna be quite powerful. But yeah, if I want to do any sort of like hardcore optimizations, the vendor tools will be the ones to use. But that will not be for a good while anyway. But yeah, that's pretty nice. What ASIC are you building? What is the project? Yeah, what is the project that you're building to be created? I find the hardware stuff quite interesting actually, but I just don't have the time. I really want to. It's it's the. I quite like learning about how the next layer works underneath and the layer under that. Um, but yeah, I just know I don't have the time anymore. um, but yeah, maybe maybe when my son is older, if he gets really into it, maybe I'll get into it with him or something. We'll see. Yeah, so initialize the capacity when we initialize the range allocator. And then allocate the blocks. Right. How many blocks are we going to need? I guess that'll be a parameter here. Blocks capacity. Right, if you run out of blocks, it's just going to crash. Right. Allocate a heap. That has got to go. Yeah, we'll look around. So what else did we change? Size line is fine. We've got to probably change the implementation, but let's just get rid of all the heap. All right, so when you ask for an allocation, you got a size and a line. We pad the size by the worst case. So we do a line and take 1. And so this means that when we get an allocation back, we I think the user has to manually align it. Yeah, I think you get a block back. You get a block back, and then the user has to manually align it. Not the best API. It was fine for the Vulkan memory allocator because only 2 places used it. This might be more. So we might have to put 2 of these in there. Maybe there's an align offset thing. Yeah, we'll think about that. So find the block bucket with at least 1 entry in it. So we do some magic with the bits. We look at we get which power of 2 or the next power of 2, clamp it between the min max range and take away the min, so we get the bucket index. Then we search from there. So every allocation, if we find a bucket with a free block in it, it's guaranteed to have enough size without checking anything. Or without searching, basically. So the only search we do is potentially over an array of U16s, which should all be in the same cache, hopefully, or they might spill over into the next one. It could be optimized a bit more, I guess. We could like align memory a bit better, but there we go. So this is one saying if we don't find a free block, then allocate a new heap. We don't have that anymore. This was a feature of the Vulkan memory allocator, where it can just go and get more memory. But that's not the case anymore, so we're going to return null. So this means you've just ran out of memory or room in the buffer of some kind. There's no more range. So this is a successful allocation. So we get the block. Say it's not a free block anymore. We then tell it to so the place where we grabbed this block from the free list, we cycle it to the next one. So we basically take it off from the head of the free list. We get the size of the block. We assert if it isn't big enough. If it's exactly the right size, we return. So this could be stripped in release builds or something maybe. We don't need the heap anymore. We allocate a new block. So this one is saying that there's still room at the end of the block. That's just wasted space for the allocation. So what we do is we allocate a new free block, make it start where the wasted space will be starts in the block. So we basically split the block we are allocating in two and return the shorter side, return the side that the size the user has requested, and the rest is free memory put back into the allocator. So yeah, we probably need a way in the block to just say something like, we might need like a U16 to have some align offset. So when they get a range back, it's start plus align offset. But then you could just manually align it yourself. Yeah. Well, the align offset will store how do I get back to the original start. Yeah. So the user just uses the start field and the end field. That'll be it. So effectively, we're going to do something like this. So we'll work out this sort of align offset. New aligned start is equal to block start, and we want to do a align. So round up a line, integer round up a line. So round up this to whatever the requested alignment is. And then we work out what's known as the align offset, which is aligned start take away block start. Right. Now the block start gets set to the aligned start, and then the align offset is equal to align offset. So this is how we can restore it back to what it was before. So we don't align the memory and then just forget the memory that came before. We can just wind it back. So in the deallocate, when we get the block, we can simply do it here. Right, start minus equals block align offset, and then we can clear the align offset to 0. Right, that'd be pretty sweet. We'll tap out. I'm submitting a Cordic core, so a chip which can do basic maths. So it's not a very high speed design given the limitations of fabrication process. Cool. Nice. Awesome. So are you looking into getting um, into hardware design, like getting into the industry someday and designing like chips for like I think my boy's calling me. Yeah, you think about yeah, you basically think about trying to get into the industry and designing hardware chips at some point, or just having fun and learning. What is the Tracy profiler? Sounds familiar. Ah, cool. Oh, this one's a lot. Right, I've seen this actually. Oh yeah, this one's definitely a lot more bells and whistles. Well, well, well. Wow, people go full ham, don't they? This has got information. Yeah, it's kind of, I guess, kind of right. You've got your, yeah, it's like a timeline and you've got different layers to it. Yeah, I see what you're saying. Yeah, there's different ways to do it. Yeah, typically you want to do this if you, yeah. But there's always different cores as well. It's pretty sweet. Yeah, what's nice about my renderer is I only have one queue. I'm not doing any async queues. Well, I might do async transfer in the future, but that'll be a different system. But I won't have any async compute because the whole thing is compute, and the whole point of async compute is if you rasterize triangles, there's a separate piece of hardware which does the triangle rasterization. So when that thing's busy, your compute units are just sat there doing nothing. So the way graphics drivers um, want you to fill that work up is use the async compute queue, and so they can't search through the queue even more to see whether there's any compute, because you could have a whole bunch of draw commands like queued up, so it'd be quite a long scan for them to do it. So if you make another queue where you put the async work on, and then it just looks at the top and it's like, oh, there's a dispatch, and it'll go and use it. Um, but yeah, um, luckily because I'm doing compute only, I don't need to use any of that because it does make the API a lot more complicated, or the implementation code a lot more complicated. Right, it's pretty sweet. So the dialog looks fine. I don't see any mention of heap. So I'm going to go back up here and look for the word heap. Right. So, yeah, so this is now stored in the allocator itself. So it's allocator end index. So this is the block that's referencing memory, which is physically at the end of the big the buffer that we're sub allocating from. That's what this end index represents. There's a start index as well. So what is the block physically at the end? Any more heap? Right, let's go on to the next one. So this is get device memory. That's a Vulkan thing, so it's not part of this API. Right, what else? Reset. Yeah, the reset would come in handy, or is going to come in handy probably. So it mentions heaps though. So it goes over all the heaps, and then it goes allocates a new block. Right, let's figure this one out. So allocates a new block. Where's the clear? Ah, there's a clear. Clears all blocks. Oh, and we did the clear all heaps. Right, so clears all blocks. Zeros that. Yeah, this makes sense. So what we want to do is allocate a new block. Mark it as free. Make it use the whole capacity of the allocator. And set it as a free list head. And then set the start and end block pointers or indices, right, to be the block that we've just allocated. So there's one block covers the whole buffer and kabam. Print prints a block, kind of handy, right? There's a heap index in there, get rid of that. I don't think we changed anything to do with the, with the align offset. Yeah. Just put that in there. Cool. So this is the validate function. So I have a test function and a validate function because this is the type of thing where very easy to think it's correct, but it's actually wrong. So you do need to have some test code. So the validate function just basically goes around and makes sure all of the link lists can see every single block. And then wait a minute, I got my dad calling. Let me just answer him. Be right back. Right, welcome back, everybody. Sorry, just my dad. Wanted to talk about Christmas and things. Got some more plans now, hopefully. Right, where was we? Awesome, Rohan. So Rohan was saying, yeah, the goal is to get a hardware engineering role. Cool. This is a long-term goal, but yeah, this tap out adventure is learn exercise. Very cool. That's sweet. Yeah, I'm not sure how people typically get into those roles. I assume they go to uni and then they get into a company at like a, you know, some kind of role, and then they work their way into the role they want to be in or something. Yeah, it's always bizarre. Yeah, I don't understand how the industry how industries work and get people in the right places. Um, but yeah, right. This validation function. Yeah, so we just want to make sure we can run a test. I barely write test code, but a memory allocator, especially a heap allocator where you're tracking lots of different blocks. Some are free, some are not free. They've got linked lists that go everywhere. There's a free linked list. There's a list of blocks that are physically next to each other in memory. Sorry, blocks that reference memory which is physically next to each other. So you can go all the way from the start to the so you can take a block and see which one is next to it and then join them together, that sort of thing. So you want to make sure all the linked lists make sense. So this just validates all the blocks. It does some things. So this one validates all the blocks that bookkeep the memory that is physically contiguous. You know, this one used to go over all these heaps, but we don't have heaps in this version. So there's just one heap, which is the buffer you're sub-allocating from. So we go over and just make sure that all of the start and end indices are physically, they join, so there's no gaps, so we're not wasting any memory. And we toggle the validate TikTok bit. So there's a bit which basically gets toggled, and we use that bit to know whether every block has been visited in these free lists, and it only needs, every time you call the validate function, it toggles it, and it just needs to match the one in the allocator, and that's how we know that every block has been visited. So what we're saying here is get the block if it's worthy of being in the free list because it's large enough. Yeah, so if it's not worthy of being in the free list, we tick, we toggle the TikTok bit. And then this just ensures that all of the memories doesn't have any gaps, and then just keep going around and doing that. So the reason why we don't do the free list ones is because we look over all the free list in a second anyway. This visits all the blocks in the unused list. Yeah, I don't get why the unused lists, aren't these the same as these ones? A bit confused. Oh well. Oh, no. Yeah, so if they're small enough. Right. These are the sort of unallocated blocks. So you have, when you've joined a bunch of blocks together and you've just got this sort of block that's pointing to no memory, that one goes in the unused list. So you can quickly get a new block by just taking it off that free list. So you toggle all those ones. Now you go over all the free lists, and you're making sure that everything within the free lists is the right size based on the power of 2. You know, it's no more, you know, it's in the right, yeah, it's the right size basically for that free list. And then, you know, it has to be within a certain power of 2 range. Then we also toggle the TikTok bit, obviously. And then finally, we go over every single block that's been allocated. And we make sure that the TikTok bit is equal to the, or the, of the block is equal to the one of the allocator. And that means that we've not, that means we've visited every single block that's in circulation. And one hasn't just gone missing. So that's basically the validation step. So I don't think there's any more heap references. Right. So that's allocator capacity. And then silly boy. Do you create separate allocators for different Vulkan memory requirements or use different pools within the main allocator? Good question. So the approach I typically take for this Vulkan API is avoiding having to do any of those things. So what I mean by that in more detail is when I create my buffer, all of my usage flags are the same. So these are always on GPU memory. So when we have a concept of a buffer resource, it's always in GPU memory. There is no upload or read back buffer which the user can create. Those are created internally by the GPU API. So there's one upload buffer and one read back buffer that you just use as some API where you say, hey, upload this to this buffer. So it puts it in the staging buffer temporarily and then it copies it. So those buffers are created in different, yeah. So this is, yeah, so here's the upload buffer creation. So, you know, there's 2 active frames going, so we create 2 upload buffers, and let's do that manually. And these ones, you just, you know, call the VK memory allocate stuff directly, and we just do that at boot. But the buffers that we use here, for the most part, actually that might be problematic. The usage flags are the same, meaning they should have the same memory type index. I think this might have bugged me up actually. That's probably a bug. They could become a different memory type index. Yeah, and in doing so, basically, if we take a look at the initialize function here, we initialize these when we initialize the backend, we just find the memory type index for a buffer and one for an image. So again, our images are they're always sampled, storage, and transfer destination. We don't do anything else because we're using compute only. We don't really need anything else. Obviously, the more of these you have on, the worse performance it would be on some drivers. So you really got to be careful with this. But for us, because we're not using anything else, it just... Right. I've put all the bits on here. all the usage flags on here. Yeah, then I just find the appropriate memory type index. Maybe this stuff needs to look at again. Yeah, it very much does. I'm hoping this is how GPU APIs end up going. They stop trying to do all this like special cases and stuff, because it really adds a lot of complication. Um, you know, it would be great if we just got an API from a vendor that was like low level or more low level. Right, so that seems like the validate function is good. So the test one just basically makes a bunch of random indices, and then it just goes over all those indices, and if it's allocated, it deallocates. If it's not allocated, it allocates a random number. Right. Cool. Heap, alloc, we don't have any of these anymore. We don't have heaps in this implementation. You get a block index, get a block from a block index. Allocated blocks, the first look in the unused list. Right, there's a heap index thing here, we don't have that anymore. Neat. Deallocate. Anything to do with heap laying about here? Right, there's heap stuff. We should not be deallocating the final block from the allocator. Yeah, so if it's a free block removed from free list, if... Wait a minute. Why have I ever got if statements around these? Huh. Yeah, these should always be true, I think. I don't know. We'll leave it in there. So this one's getting the heap. And saying if this is the last block or the first block in the physically... Yeah, in the buffer we're sub-allocating from, then cycle it to the next entry. Add the block to the unused list. Cool, cool, cool. Right, I don't think there's anything to do with heap there anymore. Neat. What's next? Right, next free list index, cool, set. Right, that's it. Should be it. So now we have ourselves this custom range allocator. So now I'll be able to make a buffer filled with ellipsoids and then sub-allocate from that all the ellipsoids that we want. So that'd be pretty sweet. So the next thing we'll do is actually create that buffer and the data type. So we need a buffer for the number of, sorry, the buffer for the ellipsoids and probably a buffer for the model as well. Yeah. See, for the model, you want like a pool allocator, though, right? You just want to allocate one. You just want to allocate another slot, but we don't. Right, that will probably come from a CPU side backed allocation anyway. So we probably won't need a special GPU one. Yeah. So I think we can get. So you can probably have like the models, buffer, model, ellipsoids, buffer, right? These will be our two new things that we just got to fill in. Awesome. End up hashing the requirements and having different pools within the allocator, right? Yeah, I see. Yeah, I think I did that in the past as well. Yeah. Yeah, you might as well, I guess, because you end up just, otherwise you have different sort of. If yours is similar to mine, where you have like a big array of blocks that you sort of just have a linked list of sometimes, or you bump allocate the block off, um, you'd have separate arrays of those and it'd just be wasteful. You'd be able to reuse that same block array. Yeah, should be should be alright. Yeah, I think I did that in the past too. You you probably don't need. Uh, you could probably get away with just an array of them, maybe, because there's only 32 memory types. Potentially. But yeah. Right, I'm just going to take a quick break, get a drink, and then we'll initialize these buffers, make the data types, and get the sort of code in for creating a model and stuff like that. Right, so BRB, enjoy the tunes. Alright, welcome back everyone. Got myself a nice peppermint tea. Oh yeah. Nice and warm. Look at that smoke effect. Maybe. Very subtle. Right. So, models. We got some GPU buffers. One for the models, one for the model ellipsoids. Also, we'll get to use that new GPU range allocator, right, for the model ellipsoids allocator. So that will allow us to sub-allocate from the ellipsoids buffer. Be pretty cool. So yeah, we'll get initializing these things, but first, let's design ourselves a couple of data structures. So I think we've already got them for the this one. I think it's called the binned ellipsoid, and that is because it was before we did the tile binner, and then I did the tile binner. I was like, this doesn't make any sense anymore. So, oh, this is generated. Right. So it comes from the generated file. So we've got a little code generator. On the database one. Cool. Yes, in the future I want to pack it down. Yeah. Another reason why I want to switch from Windows, I can't figure out how I can do custom syntax highlighting. I don't know how this thing works. Interesting. I don't think you get C in this. I think you got to say, oh, it's C++. Microsoft Visual C++. Well, that didn't work. Did I put a dot in there? That's why. No, I didn't. Maybe I got to restart it. I don't know how this thing works. But anyway, one day. So effectively, we did, you know, it's a custom file format I made so I can code generate encoding and decoding stuff, and it packs it nicely, and you know, it's great. So this is targeting GPU and binary format. So we want to change this to be known as a model ellipsoid, right? It's got a world from ellipsoid at the moment. It's probably wrong. Wait, we'll keep this one around because the current renderer works with this one, but we'll make a new one. So this new one will be called the model ellipsoid. So this one's going to have a model from ellipsoid transform, right? How do we take into model space? Yes. Then it's going to have a I wonder what I did with that. Oh yeah. Good. Right. No wait. Transform. Right, okay, so a material index and an alpha for transparency. Yeah, I got to think about more of this later on. Yeah, ideally later on it will be nicely packed, so it will fit nicer into some caches basically, and be a lot more efficient. The GPU. And then we want to have a model. So the idea of a model is, so this one will be available on the GPU. Hmm. So for now, we'll just store the ellipsoid's start index. This is going to be like a range allocated from that range allocator. We need to store like a number of ellipsoids, right? And then we probably want more information, like to do with like how do we get it? No. It's not. Yeah, we won't need to transform. That belongs to the instance. What else would you have? I think that'll be it for now. Cool. Right. So if we run the code generator. So I'm a bit worried about running my code generator because the problem with it is that um, it actually uses the yeah, we've already got a compiled version. The problem is when you compile it, is it actually depends on quite a lot of the game code. And if that game code is not compiling, it doesn't compile, and then yeah, so we'll call the binary directly, so it's in the build directory encoder gen, and it just runs and generates everything done. Cool, so we go to the generated file. Here they are. They've not got any extra sort of macros to help decode stuff because there's no packed things in there. But yeah, that'll do for now. But yeah, later on we'll get it all nice and packed and see how the performance compares. Right. So let's go to the graphics side of things and go to graphics initialize. Now in here, we're going to allocate the buffers and things. So yeah. Guess we can stick it up here. So we can call it like models capacity 64K. Must be good enough. Ellipsoids. Model ellipsoids capacity. So what's the maximum number of ellipsoids? Well, you kind of want to say like per. No. So in total, we could probably say 1,000,000. I don't know. See, when we do like, probably do like some kind of like skinning thing as well, is you'd need to take those model ellipsoids and those get moved into yeah, they'll need to get Probably need a different data structure, and we'll need another range allocator for that, I think. But yeah, I would say, so let's say on average for every model, because I think there's going to be, I think maybe let's overdo it. So we did, crying out loud. Nice. So we times about 128, it's only 8 million. Yeah, I guess let's do this times 8. Sorry, times 128. Always change it. So on average, 128 per model. Let's use those two lovely constants. So we'll eventually get rid of this buffer here. So model buffer. These are the models. Right. Model ellipsoids. Neat. And then finally, there is the graphics range allocator. Initialize. Oh, I called it GPU range allocator. Bit wrong. Sort that one out. So in the header file as well. Neat. Neat. Cool. Just gotta change these GPU range things now. Ah, crap! It didn't go the full way. No. Didn't do all the functions. Alright, do that again. Cool. I accidentally took off this damn thing. Nice. Right, let's do the capital letter one. Cool. Right. So back to here, we was actually trying to initialize it. So that was in, so for models. Right. So graphics range allocator initialize. We're going to instantiate ggfx model ellipsoids allocator. So what's the capacity of this? How many elements? Well, that is this many elements, and the number of blocks that we'll need is actually just the maximum number of models, right? Because, well, if you was to satisfy, yeah, if you was to completely saturate the ellipsoids buffer completely, you would need no more blocks than there are number of models, right? So that's pretty cool. That works out quite nicely, actually. Maybe you might need one more, but we'll probably never get to the place where you fill up the number of models anyway. So being off by one is not the end of the world. Cool, so now those are initialized. So we would actually get this from the model. What would we do? Yeah, these two structures and that would typically come from an asset, but we don't actually have the asset yet. When we make the editor, we'll make the asset and plumb it into this graphic side of things, but we just want to get something as a placeholder so we can get it up and running and then plug that bit in afterwards. So let's take a look at the old API we used to have for the BVH one. So where is it? I think it was part of the public thing. Public API, the graphic system. Maybe. Oh, there's a model ID. Right, so we only had a hard-coded model ID. Right. And we had like a hard-coded box and a tile and a player and the basic one for the material. We could get this one going for now. Yeah, let's get this one going for now. So we'll initialize these ones. Right. Okay, so I think we'll build. I got an idea. So I still think we can just define a an ID. This ID is going to be known as the graphics model ID. What did we already call it that? Damn it. Well, we'll try and get both working. Define object pool. So graphics model and the graphics model ID. So it just code generates a an object pool which is typed. So here, graphics, core object pool, graphics model, models object pool. Nice. So we'll instantiate that. So every time we make a model, we can allocate those there. Cool. So that'll be a core object pool in it. We pass in the models object pool. The allocator we're going to use is probably the static allocator if there's one laying about. I cannot see one for some reason. Static allocator, and the capacity is the number of models. Nice. So we didn't actually have an API, but we're going to make one. So I think so the game is going to be like, I don't know, right? It gives us a list of model instances with some model ID. But if that model doesn't exist yet, right, maybe there should be some other way of referring to model. Maybe we can call it like, you maybe refer to it via some kind of asset thing. Like what is the asset? Like it's like a loaded asset or something. And then you give it to the Yeah, take a look at that. Hey, struggler. Hey, what type of game you working on? Well, eventually it'll turn out as some RPG thing. I'm just trying to get the basic. Like I'm building a custom renderer. I'm building a um, which renders ellipsoids and things, and building some editors so I can build this sort of build these models out of ellipsoids and build levels and build custom materials and things. So we've got the material editor kind of most of the way there. It still need to go back to it after this though. But yeah, I think in the year 2026, whenever that one starts, so like another year away basically, then I might start prototyping the game. I'm hoping in a year's time to have the editors done so content can start to be made and probably release the editor out for people to have a bit of just a bit of a play with it. But we might be a little bit late on that one though. We'll see. So maybe a year and a half. That will all be really good. And I'm hoping just sort of release it out there as like an editor where people can have a bit of a play, make some cool stuff, and see what sort of attention I guess if there's any people who sort of like really enjoy it, and kind of try and prototype a game from there and see where I want to go with this project and how do I build this sort of like plan to take the game towards the end, basically what finalize on the actual game. I've got some ideas and take it towards the end, and how do I achieve that realistically. So yeah, that's the idea. Asset by name, asset by type. Yeah, that's the thing. I will look at the asset system, but I don't think I have typed asset handles. So yeah, that's interesting. I might benefit from those, but I don't know yet. Because I could just have like an asset ID and that's a loaded asset. But yeah. Very cool. This is where inside my warehouse. Amazon developer. That's all right. Sort of familiar to that PS2 game, Banak in the day. RPG Maker. I'm not sure. Um, it's gonna be its own little thing. Like there has definitely been. Oh, you mean Black? Right. PS2 game Black. I actually played this. I knew it was made by. Right. Red Criterion Games. Right. Okay. Cool. Cool. Interesting. But yeah, it's its own little thing. It's just a little weird ellipsoid renderer. I'm not trying to sort of do things which are typically done in rendering. Just having fun, doing some weird things. You know, because we get a lot of games which are just very samey, but it's not. I'm not just reinventing the wheel on everything. There are, I'm using PBR, so physically based rendering. Um, but yeah, it'd be good if there's just a little bit of a twist or a spin, and just be interesting. Yeah, I think you got to have at least a good twist that people can really get onto. It's PC game that basically an engine that lets you create games using their assets, kind of like right. Hey Perry, Perry, how's it going? I'm doing good, thank you. Just just started the Christmas break. It's gonna be good. Just been yeah, I spent a little time yesterday programming up a little profiler for the game, built into the game. Getting there. pretty cool. But also when I did some Christmas shopping, last minute Christmas shopping, and I'll be preparing for Christmas soon because I'll be hosting Christmas. Got both sides of the family coming over, so it's gonna be busy. But it's cool. We are making sounds way more interesting and involved. Yeah, so I don't. So I think I do want to ship an editor with it in some regard, and I don't think I want it to be like. Yeah, I think people might be able to mod stuff with it. I'm still not sure on that. Um, it all depends on what the final game is, but um, definitely in a year's time though, I do want to ship an editor out that people can just have a play with and just make things with it that it won't necessarily be um it was just like an interesting sort of art exploration tool, you know, making models out of ellipsoids, making them animate, and just if that sparks someone's interest, then maybe, you know, maybe that's a person who I could work with in the future or something. You know, it's just a sort of a way to sort of just get some um just probing the outside world a bit and just seeing what reception there is to that sort of look. Um, but yeah, before I take it into an actual, you know, design the game and this is the direction we're going, because I can do art, but it's something I don't want to wear. I don't want to switch to the art hat and be doing all the art for the game. So I need to figure out how you know I could entice someone to want to make art for it. Um, but yeah. There's loads of little directions I could go in the future, but I just got to figure that one out as things go. Do you know, do a remaster PS3 and Child Drake's a deception? I like that storyline. Yeah. Well, yeah, I can't really touch that game. Sony IP, right? But yeah, it will not be. Yeah. I've been on Christmas break since late October. Wow. Coincides to a reduction in force and engineering randomly end of the year. Hmm. Have you been made redundant, or is that just yeah? Did they make you redundant? Right, let's take a look at the asset system. It's really basic. It just is an abstraction over the file system. So you open up a path. So that it can either come from like a packed asset in release builds, but then in debug builds, it just loads it from a file. You get an asset ID. Right, it's a loaded thing. It's in memory. You can use it. So this has a problem where if it's loaded into memory and you're just sticking it on the GPU anyway, it means you're going to have it in CPU memory and on GPU memory at the same time. And if you just use the asset ID as some way to reference something, it's not going to be you have wasted memory, right? You just want to use this when you are loading the asset in and then get rid of it probably. Or it's the thing you keep around loaded into memory because you use it frequently, right? So only while you need it, you keep it loaded into memory. Okay, so we can't probably not best to use the asset ID. So in terms of a model instance, you have these model IDs. Um, right, so you could say I'm entering this sort of region now. Load me this asset. That can work. Um, and then that will give you a model ID. But then like the CPU thread typically makes a queue and then gives that, well, it just makes like an arrays of data, and it's called like a graphics payload, and it gives that payload to the GPU to then render on a different thread. So we can do another game simulation without having to wait for the rendering to finish, or submitting all the rendering commands. So the CPU side asking to do, so that system isn't actually in yet, but I'm just thinking about it and preparing for it because it is something I'm definitely doing. So, but having an API where you ask the renderer, you know, load this asset for me and give me an ID back is not really a thing you want to do. Otherwise, you got to put a lock in or something, and it's just a bit weird. Typically, you just want to have a way where you can just give the renderer all of the data and it can sort everything out. So we could take the hash of the path. You could see if that hash of the path has been loaded yet. If it has, and then you end up using that one, then if it isn't, you load it. But then obviously if you've hashed the path, you don't really have the path anymore. So you've either got to have like a hash lookup table for a path somehow, or hmm. This project is doing it all from scratch. Are you planning on to do the audio, 3D graphics yourself, sorry, physics yourself, or do you plan on using existing libraries? So I don't know anything about audio. I wanted to try it out. I've seen there's projects like Mini Audio. I would probably use that. I know there's other ones that bigger companies use, like Wise and um, Fmod as well is another one. They're quite popular. Um, but I don't know. I typically like to make everything myself, but that is one where I'll probably need another programmer eventually. And that would be part of the plan where it's like we've picked a direction with a game, maybe built some a prototype of some kind, and sort of tried to plan out what is this thing we're trying to make in the end, and then realistically, how do we do it? So I'll probably need another programmer of some kind to get that going, and then obviously collaborations with people to make audio. Um, Physics, I don't know if we're going to be having physics in the game. It might just be very basic stuff, and in which case I'm just going to program it up. I've done 2D physics in the past. It probably won't be like a full-on physics engine. It will just be very basic things, if anything. But I was playing Astro Bot. I actually haven't played it for a couple of weeks, but I'm about halfway through, which is typically how most of my games go, and they end up just getting parked. But you've played Astro, they've got all these little like objects that are just laying about and you can hit them and the world's very reactive. I still think it very much was or there's like this grass you can run through and it's sort of like, you know, it's just a very reactive world and it's really cool and really nice. Um, Having stuff like that in the game really makes the game feel a lot better. Maybe we might do that, but it definitely does add time to development. But in which case that would be um, yeah, something to yeah, definitely plan out for. Yeah, my current stance is not doing much physics, but if we did, it will be for that sort of stuff, right? Make it feel reactive to the player, so it's pleasant. I was speaking to my manager, who I was good friends with. My team went from 15 to 7. CEO also got let go. Interesting. We think it's because they didn't hit the profit milestones after COVID, right? Was a software shop that built medical home health software for nurses and doctors. Cool. Also, sorry for yapping about a lot of demeanor. That's all right. No worries. Interesting. But yeah, so are you still? I don't know if you got let go or not. But yeah, if you got let go, I'm sorry to hear that. But yeah, it sounds pretty tough. Hope you get on your feet soon. But yeah, medical home health software. Oh man. Yeah, well, I hope you get that sorted out soon. It's the worst time to get unemployed, isn't it? Around Christmas. I need some advice. I want to create a game for mobile and PC that will support multiplayer in Unity. I've been working on both Unity and Unreal for the next past few years now. Not really sure where to start. Is it better to get gameplay first, then make a multiplayer game, or the other way around? So I'm not really too much into Unity or Unreal, but typically with like multiplayer, you want to get multiplayer in right away, because multiplayer, like how you synchronize the objects over the network, is a problem that needs to be solved right away. If not, it's a pain to do it later. Um, but yeah, maybe just get the game prototype done. Once you have a prototype, then that code is all throwaway. You put it to the side. You copy paste the bits in which makes sense, right, for the project, for the new project. And or maybe you sort of just copy paste it and you got this project and you completely refactor it and get it working with multiplayer. Um, but don't go in and build the whole game and then be like, I'm adding multiplayer to it now, because it will not go well. Um, but yeah, sounds like a lot of work on mobile and PC though. Um, but yeah. Any plans for the character AI in case of varying levels of difficulty? Rushing or grounded. Thank you for the bits there, Oren. Appreciate it. Any plans for game character AI in case of varying levels of difficulty? Yeah, I've definitely not thought of those stuff yet. Yeah, I do not know. Yeah, I'm not sure. Yeah, not sure the type of game is yet, whether it's this sort of linear story thing you follow through or an open world type of thing where the player can go anywhere and do anything. That is yet to be decided. So yeah, completely completely not. Um, yeah, no plans yet. Um, right, so this model instance thing. how do we, from the game side, be like, I want to reference this asset, but I don't want to have it open, right? I think that's just the thing, right? I don't have it open, but I also don't want to be passing around a string, right? So we can either change the asset system here and have a way to essentially have a hash of the path and get a path back. So, I think the way games typically do is if you have like an asset system, you typically bundle your assets with the game. You can have a way to take a kind of like an ID, like a hash of the path or something, and yeah, take an ID and get a path back. We've already got this, but our ID in our system is kind of like it's loaded and ready to go. It's in memory, right? So we're not passing around pointers. So we could have like a kind of like a weak reference, right? This is kind of like what we want is like this weak asset reference. So there's it's just different terminology how you want to say it. But yeah, maybe. So the problem is we don't really have. So how could we? We just got an assets folder for now. So you just refer to things via a path. We could go over everything in the assets folder and just do recursive descent and just hash everything up. So hash all the file paths up. Take that, and then we've got some lookup table from hash to path, meaning whenever you try and open up a asset, you can also do it with this hashed path. Then you could pass this around very cheaply without passing a whole path pointer around. You could also have a deduplication table where you could say to the asset system, take this path and give me a hash back, or give me an ID back. That way you could get so it's just a string deduplication system basically. And then you could always open it up with that. Yeah, that could be a way to do it. So whenever you want to refer So from the game side, whenever you make a model instance, so say within like you probably reference some kind of asset. You take that path the asset is in the assets folder. And so if you deduplicate it, it's always got to give you the same thing back. So the easiest thing to do is probably just hash the path. So, right. Yeah. So if we were to, so the problem with this asset system is what? Well, it's got to work across multiple threads. Path to ID map. See, if you had for now, we don't have to worry about multiple threads because we don't really have multiple threads. A good idea would probably just be, yeah, let's just get a very quick version done. So there's a way to open. You can open with a hash. This be known as like a asset. Something like that. So you can say open up with this thing. Yeah, that'd be cool. And there's a way to obviously take the so in the future we will need to make sure that the asset system is at least populated with all of the hashes beforehand or something. Yeah, we can work it out. So you're just taking a string. Now the thing is you got to make sure these strings are all relative from the asset folder and all forward slashes, no backslashes, that sort of stuff. Yeah. There or not. Doing that. Right. So I think we'll have a hash table. With a string and a path hash. See, if I called it an asset hash, it would make it seem like the contents is hashed. And that'll be wrong. Path to... Wait, what way around do you want to do it? You probably want to say hash to path. The problem is with my... The problem is with my hash tables is, well, the way they currently work is they do a key comparison as well as a hash comparison. But for speed reasons, you might want to just do the hash comparison and just accept. Just make sure your just ensure that your hashes don't collide. Right. So we initialize this. ID. That's entire database engine for asset library. Small database engine can be written. Yeah. In-memory database. This is the way. Yeah, it will be definitely more. There will be a little bit more complication because in release builds it will come from some kind of like single file where you got a bunch of files in it. But yeah, currently it's just a wrapper around F open. That's all it is. Stack allocator, assets. There's the hash function. How do we hash the key? It's a U64. We've got one of those. I need to make a key Well, it's already a hash, that's the thing. So we want to pass in it's already a hash, it's just so dumb. It's not really nothing, it's more of like, so the key, the key is a hash. I'm so damn silly. I really need a different hash table, but yeah. Let's just say U64. We're just gonna do nothing. Yeah, I could throw it through another hash function again. Maybe. Yeah, I guess let's throw it through a hash function again. String key size of U64. Just in case we want to do a random U64 number again, but that's not a hash, so hashing it will be better. Key comparison. Dereference to U64A. Deref U64B. Voila. So these are our two new functions that we just simply pass into there and here. Right, so whenever we try and make this, we want to, where's the find? Is it like a find or insert? Yeah, we'll do that. Just do a find or insert into the hash to, so let's just pre-hash it. Call string hash. Just hashes the count and the whole string into one big hash. Then we so it takes in a call string hash. Right. Neat. Passes in the hash. Tells us if it's new, do we care? Probably not. I think we already care about it. We'll write back the memory anyway. So write back the string and then just return the hash. Cool. So now, so this is what we'll be using basically. It'll be cool. So in the renderer, we'll just use, so for the model instance, you will reference the model via this thing here. And then if it's not loaded, the graphics system can open it via a hash. So that will work like this. Open with hash. So this will just look up in that, doing a find. pass in the path hash, gives you back a core string. Path pointer. And then we want to assert that it does exist. Has been created without it's been created without using asset path hash. So is not in the hash to path map. Sweet. Then we simply just return asset path, the reference of path pointer, and voila. So that'd be pretty sweet. Looking forward to using that. Nice. So yeah, the only bad thing about this is not typed. So you could end up loading, referencing the wrong asset, but you can just error with that on the renderer side, I guess. Nice. Reminds me of sketchy hash table implementations like map of map. Oh yeah. Yeah, map with a vector in there of map. Yeah, great. Yeah, it's not the thing I'm typically a fan of doing, but yeah. Maybe I'll solve it later. I think I do want another hash table where I just use the hash and I don't do a key check. It does simplify the implementation a lot. Yes, the model instance will have a world from local transform. Nice. Very cool. Cool. So that means when from the problem is, right, is we don't actually have a asset to load yet. So what we're going to do is we're just going to pretend it's this thing. Standing in until we have model assets, and we'll have these when we make the model editor. So cool. So this enum will just go in place where the model path hash goes in, and that'll solve our problem nicely. We can yeah, that'll be good. Awesome. The next thing to do is to read over, whenever we render a frame, go over these model instances, see whether this model has been loaded yet. What do we do if it hasn't been loaded yet? Well, typically you wanna, right. Yeah, I guess you would just stall, but what we could do is make it such that if like a new level loads or you think, or no, we could just say just don't rent, yes, it. So you say, if there's a model that has, sorry, there's a model instance that has a model which is not loaded yet, just don't render it. Yeah, but load the model into memory in the background. Yeah, so we can always do stuff like that in the future. That'd be cool. So in the render frame, we're going to basically process those model instances and get some. So I've actually tried to clean this up a bit by putting into some functions. I typically don't do this. So we'll like render environment map, render ellipsoids. So I think so we could make another function which basically prepares the models. So the models will get uploaded to the GPU. So we'll go over all the model instances, basically get them ready, and by getting them onto the GPU, filtering out the ones that don't need to be rendered this frame because they're not loaded, for instance. And then once they're into GPU memory, we'll need to run some shaders, which will, what will they need to do? Yeah, so we'll run some shaders which will possibly like get the ellipsoids out that we need to render type of thing. So I wonder. Right, so this just bins the ellipsoids and that. Maybe we should just call this render models. Yeah, and just, yeah, you know, all about big functions, right? Render models. This is the way. Cool. So in here is where the fun begins. So we'll go over all those. Can I get the payload? Graphics payload. So this comes from the game thread when we have a game thread. Oh, what am I doing? GGFX payload. Nice. So we're going over all those super lovely. Oh wait, yeah, I'll call it index 0 and payload model instances. What is this thing? The stack, isn't it? Yeah, good, good, good. You get your graphics model instance. Neat. Cool. So we could probably write some code. Right, so when we boot up the game, we probably just want to go over and make all of those. Ah. Right. Yeah, so we need to have a hash table which can take us from this model path hash into a model ID. And if that's not there yet, so assets path hash into a model ID. So model hash to model ID map. So initialize one of these guys. So we go to the asset system. We should be able to just steal that code. Or a bit like that. Oh, ellipsoids. Nice. So graphic system. Add hash to model ID map. Oh yeah, this thing's not been created yet, so we need to define that. Core define hash table. That's why it wasn't helping me out. Static allocator. How many of these guys do we want? Well, as many models, basically. That's the capacity. The key is, yeah, that'll be it. Cool. So we want to use the hash table. Right. So we could probably make a bit of an internal API here at this point here, where this could be to do with the models. Sorry, that's a public header, internal header. We can make a new section to do with models. So I think we want to say that I have one which says Boolean. Graphics. Yeah, graphics, model. Model from model find. Be passing that core. Wait, sorry, assets path hash. Nice. So this will, you try to find it. If you fail to find it, you return false. But I think we'll always return true because we already have stuff loaded. Yeah, so for now I guess we'll call it find or load. Yeah, and I guess in future we'll, yeah, so that will just return a model ID. Nice. So we'll start making this API. There'll be ways to yeah, I don't. We'll have to find ways to unload models as well, but that's not really a problem to solve right now. So we'll find where this stuff is. DVH build from GPU data. That's the old one. Oh. Okay. So here's the model API. So it's going to look in that hash table. Model ID. Pointer. Core hash table. Find. It's going to be a find or insert at this point. And we're going to find so path hash, if it's new. Right. So I think we'll just say if it's new, we're going to basically bump and make a new. We'll there's these sort of hard-coded assets that we have, which are very basic, and we're just going to do that in here, just to get the system up and running. Then later on, we'll make it load from the asset file, and then after that, we can do like an async load thing where it can return false or something. Yeah, just incremental steps of that, I think. That'd be cool. So we'll do that in a second there. But then ultimately, there will be some kind of... So this will return deref of model ID pointer. And this will actually make a new one. Actually, they're always going to return that. This is just going to be stored into the hash table. Yeah, so we'll do some sort of like core object pool allocate. Right, graphics model. So we're going to get a graphics model back out. Models object pool. Address of model ID. Return the pointer. This is where we start filling it in. So this is where we're loading all that data. So there's ellipsoid start index and ellipsoid count. So this is where we get to use that range allocator to allocate a sub portion of that buffer, fill it in with ellipsoids, and then that will get uploaded to the GPU. And then this model also needs to be put onto the GPU as well. Be quite cool. Right. This is good. Okay, I'm just going to take a quick few minute break, get a nice drink of water. So we'll put in some placement temporary models here and get those uploaded to the GPU. Yeah. Right. Sounds good. Enjoy the tunes, BRB. Alright, welcome back everyone. Yeah. So, okay. So in the past, we already had a sort of model instance system, and I had this sort of like these guys. So they are laying about in the code, so we're going to fish these out. Maybe. There's one ellipsoids array right there. What's this one? Box player. Yeah, just basic coordinates and stuff. Yeah. Yeah, so we take these arrays. Should be good. So these arrays are just going to sit here. They could be static. I don't... no, it's to be build ellipsoid. Right, so we call this new one the graphics model ellipsoid, and if I remember correctly, we... Oh no, don't do that. Yes. Yeah, it's got the model from ellipsoid transform, which has these broken down into separate things anyway. Yeah, that was in... It's in model space, so it should be 0, -1 or 1. What was that in the encoder file? Yeah, we've got to be careful. These have got to be... Why are they -10? So the binned ellipse of -10 to 10, that was because I wanted to do it in... Right, in world space or something. I don't know. It was weird. I'm not sure what I was thinking there. I was thinking maybe it's still kind of... Maybe I was thinking in... Or the world ends up being centered around the player or something. So it's at worst 10, the distance of 10 from the player. So that was the reason why the world space would have been that way. Yeah. So if we make it signed norm with inside the model, that would be good. Precision and stuff. Yeah, hopefully we could pack it down into those bits. We're not actually doing this yet. I'm just making sure the comments make sense. This transform here already has these vector 3s and things. It has a translation scale and a rotation. This is just a packed version. That'd be pretty cool, right? There's one... So this gets packed into one 4-byte word, another 4-byte word, and another 4-byte word. And then that's another one, so that'll be 16 bytes, hopefully. Getting a full transform and a material and alpha. Yeah. What's the ENC file? Hey, Coffee Lover. It's a custom encoding file. So it's basically C, but with a few extra bits. I've got a whole file on it. I read up the whole thing in Markdown, like in documentation. I kind of started working on it, and then I was like, this thing needs to be designed. I made a Markdown file. I don't even know it's going to load up in the web browser because I don't know I've got the extension. Oh, I do. So it's basically you declare a bunch of C data types, but it also supports custom packing stuff, and it generates you could do arrays which are variable length, and it will make a variable length array type of thing. And it's basically an encoding system. So it could be used for files. So you can basically create file types with this, and it does versioning, and it also, when you run the code generator, it will check to make sure you haven't changed things and broken rules. Like you can't delete fields unless you do a version upgrade. And if you do a version upgrade, you mark it saying you want to do a version upgrade, and it keeps the previous version in like a database file. And that database file stores the history of all your previous versions, and you can also amend versions just in case you mess something up. And you have to provide the upgrade path if you do an upgrade. So there's a lot of friction with that, but that's the point. It also supports, you don't have to do that file type one, but yeah, it also does text. If you use target files, you can do it as text. So you have a binary representation and a text representation. You can do either or both. They've got different limitations. But you don't have to do files. You could just target the GPU, and then that would restrict you to 4-byte types. But you can do all this lovely packing stuff. I've got this like packing API, so you can say I want to use 8 bits, here's the range, and it will like intelligently, use the min and max range to sort of like pack it down and stuff like that. It's also got it's also got unions as well, and they have to be tagged unions if you use a text file format. It's got unions. Yeah, enums. It's basically just C with a few extensions and constant expression for constants. Yeah, the GPU one is pretty cool because it means I could make a file format which can then just get directly loaded into GPU memory, and it can be versioned and stuff. That'd be pretty sweet. But yeah, kind of made that. It's like 5,000 lines of code. And yeah, so it's pretty handy. The syntax highline is broken in Visual Studio. I can't even search to find out how to fix the syntax highline, because if I do it, it comes up with Visual Studio Code. And I can't find how I need to do it. Does OBS have a feature for removing your background? I got a green screen. Yeah, you can do AI stuff these days. But yeah. I got a green screen and some lights. So these lights help light my face and the background. Yeah, so anyway, back to here. Should be able to say model from ellipsoid. So how do you enter the model space? And then this will be the... Why is this thing not giving me IntelliSense? Translation, scale, rotation, right? Translation. Scale. Rotation. And material index is nothing at the moment. Alpha, let's make sure that's in there of 1. Cool, so let's see what we've got to do. It's quite easy, right? We just take these. Wait a minute. You just take these, put them here, and then make another one with 1. Should we put a comma down? Nice. So that is going to be the This one's known as the material model. So for now, let's just use this one every time, and then we can add the other ones. I just can't be bothered to keep doing that. Let's just get this one working. So whenever we're trying to load a new model temporarily, we'll just use these guys. We're going to allocate a new range. So we need to allocate a block. So actually, this can't be the GPU representation and the CPU one. Kind of sucks. So I think, yeah, I've got to have a CPU side one. Yeah, which has extra bits and bobs. Graphics model. Yeah, I could say CPU and the other one is just called GPU. But the other one's going to really come from like an asset file. This one is more about, could call it metadata. So this is going to have the block allocation, so GPU range. Is that down below somewhere? Oh, sorry. Graphics range block. So it's just a range allocator block. There's the block of memory where the ellipsoids are. On the GPU. And then, yeah, I think we'll live with that. So this metadata is going to go in this models object pool. Right, that's what we're going to get as the metadata. Well, is it metadata? The metadata typically means like stuff about metadata is maybe the wrong terminology. Typically it's like information about a file or something, right? It's whereas yeah, maybe I should just call it CPU. Can't think of a better name. Cool. Right. So what we're going to do is do a nice the graphics range block. We're going to allocate ourselves the ellipsoid. So we'll get, so for now that just come from the material ellipsoids. Alright. We're going to then call that GPU range alloc. Graphics range allocator alloc will pass in the allocator. So this is the model ellipsoids allocator. How many elements do we want? we want ellipsoids count worth. What's the alignment? We're just going to align for 1 to 1 for now, but later on when we want to do some nice packing, we might align it to something like 64, and then we can guarantee all the low bits are, you know, zeros, so we can shift it by that many and ultimately reduce the amount of bits that are needed to reference ellipsoids. So it should be so we could benefit by packing the graphics model down into even smaller amounts of memory, which would be nice. But for now, we only need to do this. So we get the block, and we say if the block could not be allocated, we need to somehow signal that. I guess we can assert for now. To do. So you would typically just fail. Yeah. To do, remove this. Assert when model ellipsoids is full. Remove this assert when we have async loading and can return false. Yep. Right, that's good. So get ourselves the block. And that's all we need for now. Nice. So we update the hash table with the new model ID and then return. Very nice. So now I've got this new function. And inside render models, we go over all the model instances and we now basically call this guy and get ourselves the graphics model ID. Ooh, we forgot something. We forgot to upload them to the GPU. Both of them to the GPU. So we'll do this will be done inside the command buffer, so we can do an upload. Upload command upload buffer. So we're going to upload to the model ellipsoids buffer. The offset is going to be block start. So this is in bytes. Multiplied by the graphics model ellipsoid. Right? Cool. And the size is ellipsoids count multiplied by size of graphics model ellipsoid. Nice. So that's going to give us back a pointer where we can copy the memory. So destination we can call it. And we'll just do a copy, call copy elements many. It's just a mem copy with multiplied by size of pointer type. Material ellipsoids. And ellipsoids count. Neat. So the next one we want to do is actually upload to the model itself on the GPU. So that will again be another one of these things. So more models buffer. We don't need to do any of this. It's already been custom allocated, right? We've got a pool allocator. So it's going to allocate a element from an array. So you just take this ID here, and you just take the, I think there's a way to go. Right, where's the index bits? How did we get those? Object pool index mask. So you and it with the index mask. Not the best API. So you just get the index part of the ID. So we could just say model index. So it strips the counter bits. And then you're just doing size of the model. That's one upload. So realistically, we will want to batch these because we're just doing, this would be a one copy command and that is not really good. But when we put it on the async queue anyway, yeah, that's when we'll do the optimizations because it'll be done async and it won't block and blah, blah, blah. So this, we're going to fill in all the bits the GPU wants to know about. So the ellipsoids count, that, and the start index, which would be block start. Neat. Right, so now the GPU has all the information it needs. Right, so what do we need to do from here? So currently, the way the system works is we have a hard-coded set of ellipsoids. There's one behind the other one. One is wide at the back, the other one is kind of unit shaped, and then it grows with random, grows and shrinks over time. And I think the one at the back does it as well, I think. I don't know. I forget. But yeah, we then tile bin those using the tile binning API, right? We start the tile binning API, we emit the ellipsoids that we want to tile bin, and then we bin them, and then we do the ray tracer. So what we need to do is make an API which goes over all. So we need to take those model instances, get those to the GPU, and then go over a model then write a shader which goes over all the model instances and takes, we probably then want to get those ellipsoids. Well, we could, yeah, you probably want to take those ellipsoids and bring them into world space because we are going to want to do skinning later, and that's going to need that. Or we could just get the ellipsoid, replace this shader here to be like, just go over all the model instances and then look at those ellipsoids transformed into world space and, do some, bin those ones basically. But I think I want to do the more involved one because we're going to be changing it anyway. And I know that for certain. So yeah, let's just do it properly the first time. So let's write a nice comment here to do. allow this function to fail if the asset is not loaded into memory yet, then simply skip this model instance this frame. If it is not loaded this frame. Yep. And also we want to make sure, probably have another to do make this function async load using async transfer, or at worst case just using the yeah, just do that. Cool. Right, so now we do the upload of the model instances. So we get the, so what you want to do is we need a GPU buffer of, we need a GPU buffer here. So this one is in, right, that's the one that's CPU visible. Sorry, for the game thread, isn't it, to give us. What did I used to have in the shared build instance? Yeah, it was tailored towards the BVH. I don't know why I did it that way. It shouldn't really be named that way. It should be agnostic. It's a little weird. Right, so I think we'll make, let's go to my encoder stuff. Maybe, maybe we just give these the name like GPU, CPU, and then it allows us to, yeah, probably got some name collisions, that's the issue. So we give this the name like GPU. Or you could call it packed. Model instance packed GP graphics model packed. And then you sort of like unpack it. Yeah, you just call it the packed version. Because it will be packed. Right, that'd be nice. Nice. So we'll need a model instance packed. So this will need to reference a model. And it'll also need a transform. This will be a world from model. And it will need to be unit length scale. Unless we use a full-on proper matrix. Yeah, we want to use a proper matrix here. So we get the non-uniform scaling. Um, yeah, so we'll need to have a custom packed version of that. So we probably pack them down to float 16s and it should be good enough. That's 12 floats going down as 12 times 4. Um, that's 48 down to 24 bytes. So then you've got, so it's 24 bytes. So maybe you can get them, you might be lucky. Yeah, maybe it's okay. You'll be able to pack that down maybe. So it's 32 bytes. You're going to have extra fields, which I'm not sure what they are yet. Well, if you're going to be doing, if you have a model instance, you're going to want to reference, right. Yeah, I see what we're going to have to do. All right, let's get this gen, and then we'll add more fields to it in a bit. Cool. So, right. I'm just gonna get another drink, and then we'll come back. We'll make another array for ellipsoids that are in world space. But we'll have a think about that. Do we need it for skinning? But we might not want to, if they're like non-skinned models, you don't want to duplicate data unnecessarily. So we'll see about it. Right. BRB. Alright, welcome back, folks. Alright, so let's think about how we're going to do this. So, right, if we have these model instances and some of them are, I guess let's do some drawing. Make some lovely squiggles. So you have your guy. Yeah, we'll make him smile. Hey, he's got some hair. No, okay. So, they're just ellipsoids, right? Nothing special. Let's make it a little bit more. Got a shoulder. Got an upper arm. Another one. There's like bones and stuff in it. So when we do like so these it's probably not going to be a whole one model. This I think we might have the characters at least. They're gonna have different customizations. So you can probably like change because if it's going to be like an RPG, you're going to want to probably have different body parts that you can change. So one model will probably be like a head, another one would be probably an arm. Maybe the hands might be different. So they won't really have a lot of ellipsoids in those models compared to stuff that's in the world. So if you were to say skin this thing, right? If we take a look at the data for a second. So you've got these in the model, there's this transform which goes from ellipsoid space to the model space, right? Whenever we want to sort of like tile bin that, we're gonna want to get it into world space and then actually take it all the way into view space and then screen space, get the, so it's going all the way from local to screen space. Goes for the full shebang. Right. And we probably optimize for funsies. Yeah, man. Well, so, yeah, optimizing is definitely fun, but yeah, especially doing GPU stuff, you need to do the optimizations. Well, you might be able to get away with it if it's not that big of a game, but yeah. Funny this. Yeah. Yeah, I just misread it. It's basically what I do. I see some text and I just sort of like add my own spin on it. Put in words that shouldn't be there, you know. Yeah. Probably doesn't help because my eyesight's a bit blurry. But yeah. But how you doing, Matthias? Welcome. Welcome, sir. So we're going from this. So in the tile binner, you'll probably eat. Yeah, okay. So we might want to have two paths. I don't know yet. Because if we move all of the ellipsoids into world space. Oh wait, they're gonna have to be for the ray tracer anyway, isn't it? Yeah. So for the ray tracer, it needs to actually operate on a on an ellipsoid, right? So yeah, and it needs to be world from ellipsoid. Okay. This bin ellipsoid might still be useful. Right. So we need to emit these guys. Bin ellipsoids. Right. So if we call this the graphics render ellipsoid, right? That'll mean I don't think we have many of these. Yeah, we'll keep it as bin ellipsoid for now, but okay. So if we make a shader which goes over all the model instances and emits these, then later on they could be skinned and it will just work. Yeah. Nice. I think so. Or maybe while we're emitting them, we can. I don't know. I think that's as far as I want to think about it. But it should be. Um. Yeah, you might have to separate the static ones and the skinned ones, and they get copied in a different shader. But ultimately, they still produce the same result. So yeah, that should be okay. Shouldn't be too much faff when we add skinning support, basically. How much is embedded file system? How much file system embedded? What does FS mean? How much embedded file system in binary is not considered malicious? I have no idea. I didn't realize it was considered malicious. Is that picked up by antivirus? Oh, good man. This project is looking cool every time I come back here. Thank you. Appreciate it. Yeah, we kind of went and redid the renderer again for like the 5th time. But we've got like an editor that we've been working on. So we've got a material editor where you can edit some basic properties of the material. It's going to have more in the future, but the basics are there. I still want to actually finish it off because, yeah. But we'll be getting back to that when this new renderer is in because the old one was very glitchy and not very performant. This one should be better. And yeah. Still got to think about an acceleration structure for GI though, like world space acceleration structure, but yeah, I just went for a screen space one. But this should do. Ought to be good enough for now. Still going to keep the screen space one though, because it's more optimized. Right, so it's making a shader. Gonna be good. Gonna be good. Alright, shaders.c. Oh yeah. Cool. Model instances emit ellipsoids. So the thing is, right? So if you take these model instances, you can't really do culling. So you can cull them in here. So you can say, hey, if they're not in the screen or in the frustum, right, don't render them. But then if you're doing GI, you kind of want them like they're not around the camera in this volume around the camera, then hold them. So you don't emit useless ellipsoids, right? You can't, if I was making an occlusion buffer without rendering anything first, or you could use last frames 1. You couldn't reject models as a whole, but maybe you could. You maybe could use the previous frames depth buffer or something and just wing it. Yeah, we can play about that in the future, but this should be alright. This should work. So model instances emit. So this is the result buffer, the ellipsoids, and the source would be the model instances. And we'll also need access to the, so model instances instance packed. We'll also need access to the model packed, so models, and then get access to the ellipsoids that we write out to. Voila. So I think per thread group, we're going to get access to a instance. So I guess we'll just delete all that code. So I think we're just going to say graphics model instance that would be dispatch group index. Voila. Then we get access to the model. Which would be model instance model index. Nice. Now we want to get the kind of probably the thread index, which would be SV dispatch group, sorry, dispatch index X. Now we're gonna copy in 32s. So we get ourselves a base index less than model dot ellipsoids count, base index plus equal 32. Then we simply just say this is our ellipsoid index, our source index, base index plus thread index. If the source index is less than the model ellipsoids count, we're going to carry on. So yeah, we have a 32 threads running in lockstep at this point because that's the wave size. We could probably make this 64, but I don't know how big the models are going to actually be, so it might be a waste. A hyper-optimized one might be you have different versions depending on how many models are in, or how many ellipsoids are in each model, like we did with the tile bin splat shader stuff. But we don't need that yet. So all we're going to do is emit. So we do you check if you're the first wave is first, and you're going to bump allocate. So you're going to get your destination base index. That's equal to E32 max. picked up by Microsoft Defender. Right. Didn't know that. How do they deal with like really big binaries in general then? So one of the threads is going to actually do the atomic add E32 onto the graphics global. So there'll be some kind of bind. So I really want to call this like the render ellipsoid. Rather than bind ellipsoid. So render ellipsoid count. Yep. That's just going to be in the global buffer somewhere, and we'll increment it by model.ellipsoids count. Then we're just going to say destination base index equal wave active min. So across all those 32 threads, let's just min the destination base index and basically read from the lane, which was the first lane. Did this. Cool. So now we've got this base index and that we can literally just compute the graphics bind ellipsoid, which will be renamed to the render ellipsoid. So say DST. So world from ellipsoid. So if we want to take a transform and turn it into a matrix. So a transform is all the individual components, and a matrix is like obviously with the rotation and scale compressed into one 3x3. So this is the model from ellipsoid matrix. So I've got a function to say matrix 3D from transform 3D. This takes in that model. Wait a minute, we've got to get the ellipsoid. Graphics model ellipsoid packed source. And we'll load that full thing in there. Ah, do we not get these? I didn't make a buffer of that, did I? How silly. So here's the render ellipsoids. These are the model ellipsoids. Neat. So model ellipsoids. So that'd be model dot ellipsoid start index. These ones we uploaded earlier, plus source index. Cool. So we read that full thing in. This will be source dot model from ellipsoid like that. Right. Then we combine it. So we preload. It's already been loaded. Yeah, but it will be unpacked at some point. So we'll put it into a local variable, world from model, and we can then say that comes from the model instance dots. Yeah. So in the future, this is actually going to be packed. So this will unpack it into our local. Then we combine the two into destination. So how this works, yeah. So multiply matrix, and then I'm using that naming convention so we can line it up and know that they're the right ones. So, you know, you're getting a world from ellipsoid, so world from ellipsoid, by multiplying these two together. That's pretty nice naming convention. So these have to line up. And if they're the other side, you got to invert it the other way around. So material index is source.material index. So I don't have multiple materials yet. We'll add that in the future as well, but it's just there so we can get it working. So we don't have to plumb it all the way through the system. Cool. That seems like the shader is complete, I think. We've got to still add some builds and stuff. So this has to be cleared every frame. So in frame initialize, there's a shader where we call it at the start. So in a very, like, just a bunch of random stuff we can do, just initialize properly. So whenever it's to 0, so every frame we bump allocate those guys. Yeah. That's just called right at the start before we call this emit ellipsoids. Right. These are very long names, so they are going to be a bit weird to see in the profiler, but there you go. This is the way. So I guess let's just double check the code and then we'll get it triggered from the CPU side. My logic is if embedded, I don't know what FS means. File system beyond, maybe. Certain size. Isn't malicious, then why is every normal binary disable data sections? I don't know. Linux still broken? Yeah, I just haven't. I wanted to like do some programming on the project in my spare time, so I didn't really sit down and go over to it. But I've made a deal with myself to spend this week, because I'm not gonna be here on Tuesday next week or Thursday next week. I'm taking that off for Christmas. So I have some family time. Dedicated family time. Well, it's family time for the whole week anyway. So the next stream is Sunday, and whenever I get some spare time to myself in this time, I'll get the Linux thing up and running. It's pretty close, but I'll get it up and running, and then I'll get the repo over, and we'll get back on Linux, because Windows is just a pain, and I just live with pain at the moment. So good code is good code. Yeah, I do like to shorten stuff though when it's very obvious. Sorry, when it is done a lot. If it's only done like 5 times, there's no point. You know, making it very short. But if it's done everywhere in the code base, make it look very short. Alright, file system. Yeah, I thought it was file system. It didn't really make sense. Hey, Temvar. Yeah, thank you. Appreciate it. Yeah, it's really cool. The thing I was hoping we have by now is you just take that source language and run it on the GPU with some restrictions, right? But 2024 still, going 2025, we don't have that, you know. And they want you to use GLSL where you don't even have enum support. You have to hash define everything. You know, I want to share that CPU and GPU code, and to some extent, yeah, so done. It's just, you know, it does have overloading support, which is kind of nice for some math stuff, but you can live without it. Overloading just makes it such that you can't. Yeah, it has its own problems. You know, the fact that C doesn't have overloading means that if I have a function forward declared in with different type parameters, it's an error. So it's quite nice. And when I read code, I can be like, oh, I know what that type is now because I read that. So it's got its pros and cons. I do like the readability of code without overloaded functions. Right, so let's double check this. So per thread group, we get a model instance, so we don't have to check if we're out of bounds. Get the model right. Thread index, nice. We could really call that a local index, really. Might be better, just in case we decide to increase it. Kind of scales. Destination base index, get the first thread within the wave. You know, if we need to scale this up any more, the wave size, it would be multiple waves, so you'd have to do some cross wave communication within the, within the thread group, so in LDS memory or something. Increment that. Render ellipsoids by the count, yep. Do the min so you share it across all threads within the wave. Get the world from model. You know, that'll be unpacked in the future. Go over all the ellipsoids. Get by 32. Get the source index by, So 32 threads are doing this all at once, basically. Unless they go over the end. Star index plus. Yep. Pick out your ellipsoid. Turn it into a matrix. Multiply, join them together and send it out. Oh, I didn't write it into the buffer. BC, render ellipsoids. Where does it go? So the destination index is DST base index plus local index. And voila. So yeah. Now let's kick this off from the CPU. Do a nice kick. Dispatch. Ugh. So realistically, we need to know. So what we're trying to do, so we probably need some kind of temporary buffer of yeah. So it'd be like a graphics model ellipsoid. Sorry, instance packed. Right. And wait a minute, did I like change all those other names? I don't think I did. Alright. Yeah, so call that one CPU. But we could probably get away with just calling that model now. And it's called packed if it's on the GPU. We could probably put that back. Then that'd be alright. Cool. There's that sort of like load thing. So rather than calling it CPU, then this one is called packed. Nice. Now these would be called packed instead. So when we instantiate these, I think they've got to use the packed names. Nice. Cool. Alright, I think that's good. Hopefully. Didn't mess that up. So what we're looking at doing is producing some kind of like model instances packed. So this would be some core alloc, and we'll use some sort of temporary allocation. Allocate an array using the frame allocator. So per frame it gets reset back to 0. So it's nice and quick. Just bump in an integer. We're allocating that type. And we, at worst, are going to use this many. But that's in the future when we can skip. So the idea is we fill in this thing. So I guess we'll get a model instance packed. So we can call this the source. And then this the destination. IDX. So we'll actually put in a new local called the model instances count. How many are we actually rendering? So we'll bump allocate them here. And then we'll just fill them in. So that'll be, in the future we can just basically continue and then we don't have to change this code here. So it should be less error prone. Wild from model is just going to copy the wild from model. But later on it will be packed. Model index, source. Right, that'll be model ID dot raw and core object pool index mask. So it just gets the low bits and that's the index. Cool, and then we just send that up to the GPU, so we basically just I guess GPU upload buffer GFX model. Do we not have model instances buffer yet? Right, let's get on that. What's the max number of model instances we're going to have? That is a good question. I don't know. We want to support at most rendering. 65,000 models is a lot. Maybe we could say 65,000 instances, but models may be only 1,000 different models. Or maybe 4K. Yeah, let's do that. So that'd be cool. Those are the instances packed. Nice. Right, so we'll just simply upload to this, which will be at an offset of 0 and a size of model instances count multiplied by the size of the model instance packed structure. And then we simply just do that copy elements. Many destination source is instances packed with model instances, yeah, just count. Nice. Nice, nice, nice. So after that, we launch that new super lovely shader. Super lovely. Which simply takes all the model instances and emits us some ellipsoids. Now, these binned ellipsoids, eh? We have got now there the binned ellipsoids. Right, so read only would be the models, the model instances. And also the model ellipsoids. Yep. And what we output is the render ellipsoids. So read write and bin ellipsoids buffer for now, but we will change that later on to a better name. So the count is, we're going to round up model instances count. And voila. Ooh. Yeah, when we do culling, we would actually want to do less because... Oh, no. You do the culling of the instances. Oh, yeah. No, don't worry. We'll still launch. When you go over all the model instances here, it might cull the instances in the shader and therefore end early and not emit any ellipsoids. Yeah. AK Mark. Have you looked into SDL3 GPU interface? Any thoughts? Yes. So my thoughts are I prefer it to web GPU for like new people who want to use it. I think my only criticism is that it's, if you like, you've got to use SDL. I don't think at least. I'm pretty sure it's just embedded into SDL. It would have been nicer if they kind of made it a separate thing. But it's pretty cool that you can just use SDL and just get the whole platform layer, the CPU side and GPU side just all together. I think for indie developers who want to make their own engine, especially if they're just doing a 2D game, just use SDL and, sorry, if you're just doing a 2D game, I think there's basically no reason, well, there's no excuse now to be using Unity. You could use SDL, control the whole, basically control a lot of the game engine and not have to pay them any money and get a lot of control and also a lot of um you know, be in control of your code base a lot more and not have to deal with just crap because Unity has designed it this way, right? You can hopefully not make your own crap you have to deal with, just for a 2D game, right? But yeah, for 3D as well, I think the API definitely does a good job, especially for indie developers. I think if people want to make their own engine, or most, you know, just not do the platform layer and then make everything else. I'll still call that engine development. I think the API is good enough for probably most indie games out there. If you happen to know Vulkan, and I do still think you can do some extra good stuff with binderless resources that you cannot do in SDL3 GPU API. But if you do binderless, you can't target the web because web GPU doesn't support it, and web GPU is the interface we have to use on there for some reason. So yeah, unless you really need some real advanced GPU features, or just want to learn Vulkan, or just, because that's the area you want to sort of get into as a career. Other than that, you might as well just use SDL3 and the GPU API because it's just, they've done some pretty good things and kept it relatively simple considering how crazy GPU APIs are at the moment. I think it's quite alright. Guys, is the SIMD? No, it's just a vector 3. So the naming is like you've got a U32 and you just got 3 of them. Right, or you got 4 of them. They're not using SIMD, they're just a structure. And they're kind of a union, so you can sort of do like a .r and GB as well, rather than just XYZ. That's all they are. And they're shared between CPU and GPU, so I can just, they've just got regular float-based alignment. Well, okay, they've got scalar alignment. They haven't got vector alignment. Yeah, they're just aligned to the scalar elements. Awesome, thanks. I have my own hacked together platform layer, which was nice for learning, but it seems could take off a load of work. Yeah, you know, um, yeah, I think you're still gonna have to abstract over SDL because using it directly is not gonna be like for your game. It might not be. Or there might be some okay, you might either have to have some like common functions which help you do stuff, or little abstractions that over SDL that just help out doing some things that you yeah, I think you can do like little like I'm not really a fan of this word, but helper functions and stuff. Or you could take the approach of really abstracting it out. I don't think the abstracting it out approach will be worth the time and effort in all honesty. So you might as well just embed SDL2 in the project and just accept this is an SDL2 game, right? Um, yeah, my only concern with SDL is that it is a bit of a big library, um, but um, yeah, but yeah, it does have a lot of compelling features though, and it's great for people who are already using Unity and are used to something big anyway. This is like short. This is definitely like SDL is like way smaller. Like orders of magnitude smaller. I don't love platform layers. I tend to just have one update function for each platform that pulls and pushes a mega strut. Right. Right, I see. Yeah, so you typically take the approach of a pure implementation. I yeah, I'm to and from this way of thinking. I do see the appeal for it, right? Especially for GPU lands or the GPU land, right? The GPU people will just make a whole renderer in that specific for that specific API they target, but then you just got so many. And when you have just such a lovely simple abstraction, when I just target compute only, right? I I think just having an abstraction just makes a ton of sense in this case. But I do see the point of if you want to target every platform, if you want to target if you want to target every platform and not have to worry about making the perfect abstraction because there will be problems with it and um where it doesn't exactly map or something like this. Um yeah. Like right now I just can't support I literally cannot support the web because my API depends on some form of bindless where we just use indices for everything. Um, yeah. So, whereas if you wrote directly for one graphics API each time, you could just rewrite that. You basically rewrite the whole thing and write a bunch of helper functions that just help you do things easier for that back end. And you can hand optimize it specifically for that back end as well. So it's kind of cool. But yeah, just more work in some cases, depending on your project, right? Right, so after we've made these render ellipsoids, I think we're basically there. I think that's it. Um, So let me just rename this actually, because I think we can get there pretty... Yeah, so I change that to render ellipsoid. And then I want to change that type name as well. Because we might use the render ellipsoids for something else other than tile binning, and it's not really binned when you sort of... Yeah, it's just a bit of a weird name, but I want to find it all first. In case... Right, changes it in the database as well. Yeah, we're doing all that. Screw it. Do it. Right. Cool. So that emits all of those render ellipsoids. So we don't need to manually upload them now. So this can go. So that means then you just tile bin them and kabam. You get the render ellipsoids, bin, and then ray trace. So hopefully that code still let's go to the main function. There is a where do I make my payload? Game update payload thing. Yeah, so we go over all of our entities and just emit these things, right? And you got a different sort of model. Right. Okay. So that should load all the same model, which is that material model. Right, this should be interesting. Let's get this compiling and then running and just see what happens. Right, so my shader compiler's complaining. We did a thing. Which is wrong. Ooh. No. I don't understand. What are you? You're a transform. We want non-uniform scaling. Oh, but amazing, it turns it into a matrix anyway. Bam. Beautiful. Beautiful. This is in the, right, where are you at? Binned ellipsoid. Yeah, so this one probably just wants to be... Later on, we'll just pack this down into something sensible, like U16. Sorry, float 16s instead of... Yeah, so it'd be 24 bytes instead of 48 bytes, because it's a 4x3 matrix. Right, so it's not a full 64 bytes. Got an implicit final row. Alright, so let's regen that. Nice. Right, so that's in the next shader along. Yeah, so... Yeah, where it takes in, moves into view space. Beautiful. What are you complaining about now? Oh, but I want to go back the other way. No. Right, so the ray tracer's got to invert a damn matrix. Yeah, that's why it was a transform. But we wanted non-uniform scaling for the model, because if you go like that, I guess we're going to invert it. It's going to slow down the shader though, isn't it? I'm doing it in so many places. Not a fan. So if we invert, because you got to bring it into the local space. Wait a minute. So we pre-invert it. Yeah, we've got to pre-invert it here. Maybe. But after we do the bidding, we need to turn it. We need to invert the matrix and write it back out. Because then in this shader, it's going to want to go the other way. And you're going to be hitting the same ellipsoid, and you just want to read the data and operate on it probably. Uh, 2 seconds. Let me just check something. So I know my normal code is wrong. Basically, the way it transfers the normal from local space to world space, and I'm trying to fix it with that adjoint matrix thing, but I tried and it didn't work. So I'm just gonna. There's that trick that was going around. Find my bookmarks on X. Where was it again? How the hell do I access my bookmarks? Alright, that ain't happening. Yeah, there's a sort of let's see if I can find it. There's that shader toy, wasn't it? Yeah, I want to be doing this basically instead in the future. Oh, he actually renamed it. Someone said you shouldn't be using adjoint, and you should actually be using ad. Oh, damn it, maths. Adjugate. There we go. So, right, let's figure this one out. So, he moves it into object space, and then he has the inverse matrix. Right, so I'm gonna have to do an inverse in the shader anyway. Basically, I'm gonna need both. There's the inverse. Yeah, right now I'm doing this. So it's completely wrong. But yeah, in the future I need to do that. I tried to get it working, but I failed. I'm not doing that now. I'll fix it off stream or something. But yeah, so it turns out what I need to do is take that. Right. So I need the matrix 3D ellipsoid. There must be a better way to do this. Inverse Because this is quite hefty. I don't want to run this code. But maybe it's cheaper than storing. It's not good. Yeah, so I want to do a... I've got to do it for all my ray tracers. And then for the normal... We calculate the normal... Oh, did it do it in world space? Oh, so it doesn't work for rotation. Yeah, that doesn't work with rotation properly. Right, okay, interesting. Right, so that's the SSAA one. That should be that fixed. That's the MSAA one. I'm still doing it in world space. Ray traced anti-aliasing. Yeah, this one does it in the local space thing, right? So you've got to take some matrix. 3D. So we don't have the scale. Ugh. Because the problem is it's got the scale and the rotation bundled together, isn't it? So in this case, it'll be unit. Probably wrong anyway, it should be unit. I see unit, normal, and then it will scale it. Then normalize it again. Incredibly wrong, but yeah, I want to correct that later. Right. So let's hope that compiles. Shoot. I didn't do E dot, did I? Ellipsoid dot. Whoopsie. Alright, let's try that. Oh, these are using transforms. Right. Dot scale is not a thing. What line is that on? 4273. Yeah. Right. Yeah, we got to get the other one. Which is wrong, obviously. Right, so that'll be something like this. Let's go back. Where's the hit position world space? Right here. Right, that's the one I wanted to copy. No, it wasn't. Oh yeah, it is. An inverse multiply into... No way. It's gonna be slow. I gotta do it again. Yeah, I need to probably store the normal in an array somewhere, like pack it down into something sensible, and then get it back out. This is going to make the renderer slower. That's okay. Do another inverse. It's terrible. It's dumb. It'll be okay. So make the wall space 1, put it back into local space. Matrix 3D. Yes, that'd be a unit length. Or a unit ellipsoid, so sphere. Cool. So where we find those? Cool. Careful here. Do that. Very bad way of doing it. There we go. Ray trace anti-aliasing. Right, okay. Did I change it all in the right places? Shading, shading. Yeah, good, 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 good. Cool. Right, let's try run that, hopefully. No. Alright, I just tried to array index with the wrong data type. It's a bug in my compiler. Where did that happen? So yeah, my compiler doesn't type check array indices apparently. I kind of messed that one right up. So that could be anywhere. I don't think it's the code where we just changed because we didn't even do an array index here, like a new one. But I think that's actually in the new shader that we wrote. So we find that one which we just got to make sure that the array indexes are integers, and then we'll be good. Ah, there you go. It's a vector. Dot x. Right. Yeah, it's something I got to sort out. Right, so now we're into fixing the CPU side compile errors. These ones are a bit easier in Visual Studio because it actually reads the error. Yeah, Clang emits the proper stuff for it. Right, what do we want? Right, where are you defined? Ah, too late. Cool. Do I need to include the asset system? So I guess it's an engine, isn't it? I think so. Cool, what are you expecting to be? A matrix? Oh yeah. So we can do non-uniform scale with that still, but we've got to turn it into a matrix 3D from transform. So it means the game can use a transform 3D and be able to change these individually, but when we turn it to a matrix and combine the rotation and scale things. Cool. Next one. Right, nothing will count here. What was that? Oh. Right, this now has to be indirect. So the issue is we don't have... We need a setup. One. So objects count needs to go. This will be an indirect launch. So it will be offset of graphics global, render ellipsoids count. Oh no. Offset of indirect arguments. This would be ellipsoids tile bin objects. Bins. Yeah. So we need a shader which fills that in. So that'd be an indirect launch. Nice. Yeah. So we need another shader that is gonna fill in those indirect arguments. It's not too difficult. So I don't think we need any constants passed up. I think we literally just access some globally available memory. So we'll call it setup. Just launch one thread, please. So I think we literally just say graphics indirect args. We put this in here. And we say equals E30 times 3. Graphics global render ellipsoids count. And you want to do a core divide round up. We're launching that many groups of 256. I think there was a bug in the other code as well. Maybe it did 32. Yeah, then 1 and 1 along the Y, 1 along the X. 0 will make it not dispatch anything. Cool. So we just need to run that shader before and make sure it finishes. So no constants. But we do need to synchronize on GPU sync resource read only on the global buffer, GPU global buffer, and the read write, or maybe write only on the indirect buffer. Nice. So the setup one is going to get called. We'll launch just one of them. 1, 1. Nice. So I think that's it. Hey, Try Catch TV, how's it going? Thank you for the raid, sir. Appreciate it. How did the stream go? Welcome everybody. How you doing? Currently working on getting our model instances working. I think we're basically there. We just have to. We're just getting it compiling and then running. We should be able to see instances from the game rendering again. Very basic though. We just got a grid of things. And we're only seeing one temporary model at the moment. We don't have ways of getting models in the game, so just hard-coded programming up. But yeah, that's about it. But yeah, well, what was you working on? But yeah, any questions, guys? Feel free to ask away. Happily answer. Objects count, rightio. So in this shader, we've got to be saying if you go past the number of render ellipsoids, don't try and bin anything past that array. Right, more compile things. We're reviewing linked profiles. Right, what do you mean by linked profiles? Shoot, you damn bugger. I didn't catch the... Okay. Match case, graphics range. I thought I caught that. I remember undoing it to fix that problem, but obviously failed. No. It's right there. Isn't it? Right there. Yeah, what's going on? Oh, it's still called GPU, isn't it? Okay. 2.6. Cool. Should be a bunch of compile errors gone there. Next one. Right, that's the packed one. Oh yeah, translation, scale, rotation. Oh yeah, so from the game side, I'm prefixing it with temp now because I oh, and they've got to say like dot raw, isn't it? So there's different models that we want to try. I've only got player and tile at the moment in there. Oh no, but there's a material one in the editor, isn't it? Hmm. Right. Ah, shoot. Where's that used? Then the entity generator, isn't it? Right, the entity generator needs to be rerun as well. Right. Hopefully that still runs. Cool, I think that worked. App is this? What? Oh, don't say it's buggered it up. And I can't get it compiling because that ain't compiling. Yeah, because the problem is I think the entity script currently relies too much on the game. Where you at, script? Right, it doesn't rely on too much. Right, so if we were to run the script entity. Right, that doesn't compile because the game doesn't compile. It uses game because it uses the things, doesn't it? Right. It uses like the custom allocator or something like that. It's kind of dumb, to be honest. Could I get rid of game? Then that would mean what? Right, we got why is it including source logic? What is going on there? This is just engine code. Oh, OS includes game.h. Of course it does. Damn it. This is a silly thing I've done. Maybe the OS system should have its own allocators and it doesn't touch. So if the OS system has its own allocators, then I just need some global static allocator and but then frame allocator as well. Yeah, I think those need to be moved into core, so we could probably do that. Yeah, what I wanted to do. So right now in the game.h, we've got this sort of thread local storage thing where we've got the static allocators there. Yeah, I'm not really sure about it, but it's just easier right now. You could probably move that into core. And then initialize those. And then I can use it in those applications that depend on the engine side of things. Yeah. Oh, I forgot I had this debug print thing. Not really the best name. But there we go. So I think just do something like this. Cool with that engine, no game with that engine. Alright, nearly there. Cool. That'll be nice. So we just need to change that into core.c. Why is that in there? That should be in game in it. Nice. Nearly there. So now we just have to do a find and replace of all of these things basically. So core TLS underscore. That'll do it. Nice. So hopefully that allows us to compile this entity generator. Oh, okay. os.c is still including. So os.c, that shouldn't be including game anymore. Pretty good. Don't know what else will be included. Is the Linux one included as well? Yeah, get out of there. What about the Windows? Oh, we're right. Right, these errors is to do with sorry. I want to compile the entity code generator. So no new line at end of file. Right. Problematic, isn't it? Right, it's been a while since I've updated this, isn't it? Right, I see. So yeah, I've just changed how like the text reader works, and I haven't updated this entity code generator. Right, next one, 388. It wants one of them. Cool. What else? Skip white space and new lines. Yeah, I didn't do Alexa, I just did a text reading thing. It's just easier. Right, cool. Oh, for crying out loud. File path again needs to be in one of those as well. Right, link errors now, nothing to do with the asset system apparently. They need the asset system as well. It's a problem, the project just gradually gets tangled, doesn't it? Right, why is this? Oh, asset system includes game.h. Who knew that? Alright, we can remove it. Because we renamed it, it's pretty great. Where else has got that in the engine? Let's have a look. GPU's got it as well. What a bugger. Get out of there. Didn't know about the game. And the editor. Might not need it. Let's just get rid of it just in case. Oh, why am I doing that? No, no, no. Right, so... Okay, so this is failing because... the asset system has got some build errors. Because we just added something new. That was 82. I'm looking at the same file. 81. Oh yeah, delete the line. Asset open. Meant to call. Expected proper archetype got Y. Right, so that's the generator actually running now. And it's only got a Y in there for some reason. Where's the Y? What line was that? 7. Right, it seems like it's reading an uninitialized memory of some kind. I don't understand why. Is it reading... reading as binary? Let's print out the string because... you know, maybe it's not null terminated and we expect it to be null terminated, but it's a size string, so... you know, thought I... it's got a Y there for some reason. Yeah, it must be to do with the text reader, like it's not, expected proper archetype got Y. So it should say not peak. Peak will, if the cursor is... we could print out the capacity. Or reader.cursor and reader.capacity. So let's just see what two numbers we get. Right. I think... yeah, I don't know. So new line, then a null terminator. What is that byte at the end? Reader text reader capacity take 1. What is that one? 121 0. Is 121 the Y? What's before that? 10. That's a new line, isn't it? Yeah, put a new line in the terminal, so it's a new line. Right, why did it end with a Y? Why did this... So we get the file size. Yeah, I'm not really a fan of this API anyway. I typically like to use just the raw functions and not go through a buffered API, but yeah, I haven't done it this time. So here the problem is, right, we've got a size back out. Right, so I shouldn't be doing a C string because it's not null terminated. So I should be doing that instead. I think that's my ultimate problem. Cool. So that apparently emitted a perfectly fine file. We'll find out. So we go in. So I'm glad we removed that restriction now, because it gets a bit weird when you have code generators that depend on the code base that is not compiling. So you need to really have pre-built binaries that are probably checked in. But there we go. We didn't even instantiate it though. I don't even know why. I'm not even custom allocating, I don't think. Yeah. All right. Cool. I think we're there. Yeah, that's not the same errors. I think that's fixed. Right, the next error was... Oh, these are meant to say... These shouldn't be dot raw. It should only be in the renderer one, because we're basically... We're meant to pass in a hash of the asset path, but we haven't got any assets yet for that model. So temporarily we got this enum, which is going to set an yes, be the hash instead at the moment. As just a stand-in thing. Alright, we're getting closer. What is this? Dot raw. And that'll be the model path hash. There we go. Cool, cool, cool. What is this? Editor dot raw. And when we try and actually load some assets, we can move it over to that, which would be pretty cool. It's running. Let's see what happens. Right, we got a failed to initialize for some reason. What's going on here? Entry size must be more than a free... Right. So it needs to be at least 16 bytes. That's okay. we can do that. It's not a big deal. Doesn't throw a spanner in the works at all. Oh, for crying out loud, you piece of work. Oh, that's okay. Sorry, I thought it was loading the wrong file. It does that sometimes in the debugger where the syntax highlighting doesn't work. It loaded the wrong. Yeah. Right, so we want to make sure that this has at least 2 pointers. We'll just say padding. Because the object pool will use the dead memory or the free slots as with 2 pointers in it. Probably get it down to 1 pointer. Alright, well, we crashed. Right, ellipsoid is full. Why is it full? It didn't even work. No. Alright, we're gonna look into that. So that's the new allocator that we wrote today. So we didn't even run the test code on it. But why does it fail? Is there no blocks? Right, it doesn't push it in the free list. So it doesn't do that because it doesn't do that because suppose the GPU one. Allocator initialize. Right, and that alloc function put it on the free list, isn't it? Makes the block. Okay. Right, I need this code. We allocate ourselves a new block, which covers the whole range of the buffer. Block is free. And then it gets added to the free list. That's the problem. So we had 0 blocks. Hopefully we get our instances working today. No. Right, so we can take a look at what these should be appearing here, or at least that's what I think they should be doing. Right. Varying a lot. Tile bin is emitting a ton of stuff. There's nothing being binned into screen tiles. Model instances emit ellipsoids is running. It's taking 2 milliseconds. That is long. Don't know why it's taking that long. Maybe there's just a lot of ellipsoids. That's just a lot. Let's take a look at the number of instances. So we put a breakpoint here. 147 instances. Okay. seem to be appropriate numbers. My next question is, how many... I don't know why this shade is taking too long. This is just weird to me. In this shader though, we want to print out the number of render ellipsoids. Because that'd be good to know. How many are we actually realistically trying to render? Yeah. So apparently we're pushing 400,000 through. That seems like a wrong number. What about... Yeah, there's not 400,000. I can tell you that. It's just... Yeah, that is way too many. So something's going wrong in this shader, maybe. I wonder... Right, so one more check. Oh, come on. There we go. So I think when we upload the... Well, I wanted to see what that number was here. Oh, that's not good. It's... Yes, it's only 2. So that's not good though, but it's not the problem. It needs to stride in bytes. Yeah. Still fine. Because that's 0 anyway. Would have been alright. Uploading a single model. So I guess my question would be, given all of them that done this, there'll be like 100 of them. What does that look like? Right, 2. Only 2. So 100 times 2 is not... Yeah. That's changed. Something's weird going on. That was 400,000 earlier. Yeah, something weird's happening. Right. So I guess I'll call it there today. So I guess we shall resume this next week. So next Sundays we'll not next be streaming. So have a nice break for Christmas. But yeah, it's good progress today at least. It seems like it's mostly in. It's just this bug fix to do. Then we should be seeing the old scene that we were seeing before we changed the renderers. We'll have to make it so the other models will still show up because it's only one type of model, but the other ones shouldn't be too bad to add. So yeah, I guess one more stream on this next week, and that should be the instances done, and we can move on to one of the other things on the rendering list. I forgot what it was now. But yeah, we'll wait until then. Right, let's find someone to raid. I hope everyone has a good Christmas. Appreciate you guys. There's a Discord if you come hang out in the meantime and chat. But yeah, I hope everyone has a good Christmas. Spend it with their family and stuff. It's raid tech. I haven't seen tech on in a while. Good old black and white theme. Yeah. I ain't seen tech for a while. It's like old school. Streamer. Awesome. Right. Have a good one, guys. Enjoy your Christmas. Have a good time. And yeah, catch you later.